Alright, in this video we're going to take a look at some initial value problems. So these are typically word problems where we not only find our indefinite integral, but we find the particular value of c that satisfies some kind of initial value. Alright, so our first example, we have f prime of x equals 3 times x to the negative 14 over 15. And we're given that f of x goes through the point negative 1, negative 9. We're asked to find f of x. So the first thing we need to do to get rid of that derivative is we need to take the antiderivative. And that antiderivative is going to be the integral of 3x to the negative 14/15, integrating with respect to x. And so when we take that integral, we're going to get 3 times the power rule for integrals. We're going to add 1 to our exponent. So negative 14/15 plus 1 is going to be 1/15. And then divide by our new exponent plus c. So if we clean that up, 3 divided by 1 over 15, that's going to be the same thing as 3 times the reciprocal, 15 over 1. And that is 45 times x to the 1 over 15 plus c. Now we're going to use this initial condition and we're going to plug in our negative 9. That is for our function value. This is equal to f of x. So we're going to plug in negative 9 for that f of x, and we're going to plug in negative 1 for our x, and we'll solve for c. So we get negative 9 equals 45 times negative 1 to the 1 over 15 plus c. Well, negative 1 to the 1 over 15 is just negative 1, so this is going to be a negative 45. So to move it to the other side, we'll add 45 to both sides. And negative 9 plus 45 is 36, is equal to that c value. So now we're just going to plug that in for our c to get our final answer. F of x is 45 times x to the 1 over 15 plus 36. All right, so that's more of a drill problem. These last two examples are application problems. So here we are finding the cost function c of x if our marginal cost, c prime of x, is equal to 0.03 e to the 0.02x, and our fixed costs are $6. So just like we started out in the last one, we want to, our c of x is going to be equal to that antiderivative of our marginal. So the antiderivative, or the integral of 0.03 e to the 0.02x with respect to x. So when we take that antiderivative, our 0.03 is just going to be a coefficient multiplied by the antiderivative of e to the 0.02x is e to the 0.02x divided by that derivative of that exponent plus c. And if we clean up that a little bit, 0.03 divided by 0.02, well, that's the same thing as 3 over 2, or 1.5, e to the 0.02x plus c. So that is our cost function, c of x. Now we're going to use the fact that our fixed costs are $6. Well, fixed cost is the cost when there is an output of 0. So that means that our cost function is going to go through the point 0, 6. So we're going to plug in 6 for our cost at an output of 0 units. And solve for c. So e to the 0.02 times 0, that's e to the 0. Anything to the 0 power, finite numbers, is equal to 1. And so this is just going to be 1.5 for this first term. So we will go ahead and subtract 1.5 from both sides. 6 minus 1.5 is 4.5 equals our c. And so that means that our cost function is going to be 1.5 e to the 0.02x plus 4.5. All right, one more example. We have the number of texts sent in units of billions per month have been changing according to this function f prime of t equals 8.1 t minus 15.9, where t is in years after 2000. In 2003, there were 9.2 billion texts per month sent out. What is the function that gives the number of texts in billions per month? All right, so that means we need to find our f of t, and that's going to be equal to our antiderivative of f prime. Here we are integrating with respect to t because that's the variable that we have in our function. And if we take this antiderivative, we'll get 8.1 times the antiderivative of t is t squared over 2. Minus 15.9 is just a constant, and so the antiderivative of a constant is that constant times t. And then we do have a plus c, because when we take a derivative of 0, or derivative of a constant, we get 0. And so going backwards, we need to have the potential of having a constant in there. So if we clean this up just a little bit, 8.1 divided by 2 is 4.05 t squared. Okay, they told us that in 2003, there were 9.2 billion texts per month. That means this function, when our t is years after 2000, so 2003 is going to be a t value of 3. Our y value, or our f of t value, is going to be 9.2. The units are all in billions per month. And so we are going to plug in 9.2 for our f of t when t is equal to 3. So we'll plug in 3 for that t value. And if we simplify, plug in the calculator, 4.05 times 3 squared minus 15.9 times 3, I get negative 11.25. And then we still have that plus c, so we'll add 11.25, and that will give us 20.45 is equal to c. So our function here is going to be f of t is equal to 4.05. We're just going to plug that c value into our answer. 4.05 t squared minus 15.9 t plus 20.45. And that will be the function that gives us the number of billions of texts sent T years after 2000.